Hey, hi guys, good morning.
Morning, sir.
Morning. Just give me a minute. All right, so let's get started. All right, so in the last class we discussed about two sample test, and today we will talk about more than two sample tests. So with this, I think we will be covered with all the different scenarios. We have talked about one sample, we talked about two samples, and now we are talking about more than two samples. Okay, so before we get into more than two samples, anybody has any questions so far, whatever we have discussed? Okay. All right. So don't worry. We will go through some good examples on Python. We will talk about the use cases, and then we'll solve, and then we will identify which test it is, and then we will go and solve that problem. And also, I'll give you a couple of exercises which you can practice so that you'll be clear with this particular topic. Okay. So we'll talk about ANOVA, and in ANOVA particularly, we'll talk about one-way ANOVA. Okay, there are two-way ANOVA also, but it is a much more advanced concept and generally, in a very specific scenario, we go with two-way ANOVA. But typically, whenever we talk about ANOVA, it is a one-way ANOVA. Okay, now what is ANOVA? Okay, so ANOVA is a acronym of analysis of variance. Okay, now what this ANOVA does is, let's suppose if you have multiple samples, more than two samples, and you have calculated the mean from each of those samples. Now you have to uh, now you have to decide or you have to conclude whether all these means are equal or these are not equal. So here there would not be three scenarios like lower tail, upper tail, or two tail. Here it is only one scenario where you will say that where your null hypothesis states that all these means are equal. Okay, all these means are equal. If you're talking about five samples, then it will be five. Otherwise, it will be n number of samples. And your alternate hypothesis says that means are not equal. It will not tell you which one is not equal, which one are equal, but it will tell that overall, all the means are not equal. So, how it will help? Now, for example, I have multiple employees with in my team, and I want to compare the productivity. Okay, so let's suppose one person has worked in a day for 5 hours, another person has done work for 6 hours. So like that, I track their productivity and utilization for every day. And then overall, I took a sample and then calculated the mean time of their utilization. So for one person, let's suppose it has come as 4.5 hours per day. For another, it has come as 5.2 hours per day. So I want to see that in my team, is everyone is working similarly or there is any kind of difference. So there I can go and apply ANOVA and I can conclude that, okay, my utilization across all my team members are the same or it's not the same, that I can conclude. Now, after this, I can further go and analyze wherever, for whichever person, the mean is kind of very low. I'll compare that person with another person and then I apply the two sample test to further prove that that person is significantly different from other person or not. So it is the first step to understand whether all the different samples are similar or not similar. So that is the first step. And if you have to do it with a two sample test, just imagine, how many possible pairs you may have to deal with. So if you have five, then typically we go with k minus 1 by 2 pairs. So here it would be 5 into 4 into 2, 20 by 10 pairs, 10 distinct pairs, you will get it, and that many number of times you have to apply the two sample test to understand which of the sample is different and which of the samples are similar. Okay. So instead of performing 10 times two sample test, rather I will go with one test ANOVA and see if all the samples are same, then no point of going and performing the two sample test. So firstly, I will apply the ANOVA. If this hypothesis is coming as true, then there is no need of two sample test. If all the samples are similar, statistically similar, then I will not go ahead and then I will perform the two sample test. If this hypothesis is coming as true, where the means are not equal, then I will go and do some diagnostic and I will go and perform these 10 different, even not, I need not to do 10 different because with the means I can clearly identify which of the samples are looking different. And then I will perform that test uh, with some other sample, and then I can statistically I can identify whether that particular sample is different or not. Okay, so this is the advantage of ANOVA, and this comes under mean test. Okay, so if you have a continuous variable, on that only you can apply this analysis of variance test. Now here, neither we will use Z distribution nor we will use T distribution. In ANOVA, we we will refer to altogether a different distribution known as F distribution. And for this F distribution, again, it's a different kind of distribution. Again, it's a probability distribution. As I mentioned that in statistics, you will find numerous distributions, and every distribution is meant for some specific requirement. Okay, so for analysis of variance, uh, people have discovered this altogether new distribution known as F distribution. For this also, there is a table, F table, which you can refer to calculate the probabilities. Or in Python, there is a separate function for ANOVA, which you will use, which will refer to the F distribution and give you the probabilities. Now, now for this also, you have to calculate the test statistics. So here we call as F test. And we will see that how we can calculate this F test. And once we calculate this F test, then we have to go and find out the p-value by referring to this F distribution, and that p-value we have to compare with the alpha value. So the approach is almost the same. First, you have to frame the hypothesis. So here we just need to, here there is only one kind of hypothesis which you can develop. The null hypothesis saying that all means are equal, and the alternate hypothesis says that means are not equal. So this is the only hypothesis you can build when you're talking about more than two samples. And after that, the second step is you have to go and calculate the test statistics, F test, and then the third is you go and compare with the alpha value. Okay, and then finally you conclude whether you should accept or reject the null hypothesis. So again, I will iterate if the test statistics, so there is intermediary stage, and after that we calculate the p-value, and that p-value will compare with alpha. So if the p-value is less than alpha value, then we'll go and reject the null hypothesis. So I'm repeating again and again. So you have to remember this point. If p-value is less than alpha value, then only we will reject the null hypothesis. Otherwise, we have to go with the null hypothesis. Now let's go and understand. So this is something, okay, I'll write it. Okay, so if you want to take notes, then take it. Here, we will talk about two things. Now, we have let's suppose we have multiple samples now. Okay, so we have sample 1, 2, 3, 4, and 5. So, and we can have many more. Okay, we have K samples. So here we will talk about two things. We will talk about variance. So how the values are varying first between the samples. We call it as between groups. Okay, this is the variance which we will analyze. Variance, you know, right? How the values are varying in each of the group. That's something, okay, we will study here. So firstly, we will understand how the variance is between the groups. So from 1 and 2, 2 to 3, 3, 4, and you know how the values are varying, that we will understand. Second, we will understand the variance within the groups. Okay. So now that would be my source. Okay. So let me now frame a table. I'll give you a step-by-step process of calculating it. I couldn't locate the slide. I had the slide on this, but it's okay. So I will try to create this table. And anywhere if it is not readable or if you are not clear, then do let me know. Okay, so let me first create this table. So first is the source. Source is like the variance for which we are doing the analysis. First is between the group. Okay, so we will calculate the sum of squared. Sum of squared is nothing but you can relate it to variance. So what is the formula of variance? If we recall, the variance is nothing but sum of squared of deviations of values from the mean. Okay, and divided by your sample size. Or if it is like sample, then we go with the degrees of freedom and minus one. Okay, so this is the formula of variance. And if you want to find out the standard deviation, we take the square root of it. This is also defined in statistics books is it is sum of squared, SS. We call it as SSX for a variable X divided by degrees of freedom. So this is called as variance, or we call it as S square or sigma S square. Okay. For sigma square, we take directly the population size, but for sample, we go with the degrees of freedom. So this is the formula for the variance for a sample. So this SS is nothing but here, sum of squared. Okay, sum of squared deviations, basically. In short, we call it as sum of squared. It is a sum of squared deviations. So first we find out the deviation, then we take the square and then we sum it up. Okay. And then we divide with the degrees of freedom. So firstly, we will calculate the sum of squared. So for sum of squared, here we are talking about between groups. Okay. So for between groups, what we do is for each of the sample, we calculate the mean. Okay. So we calculate the mean and then we calculate the global mean. So which is capital X bar, which is equal to x1 bar plus x2 bar xk bar divided by k. How many number of samples you have, you will take the mean of the means of the sample. Again, I will repeat, I'll take the mean of the means of the sample. So I'll individually go and calculate the sample means, and then I will take the mean of all these means. Too many mean word, right? So for with that, I can calculate the global mean. Now, what I will do where I was in the variance, I was taking the individual mean to find out how these means are varying with each other. I will find out the deviation of each of the means with this global mean. Okay, and then I will take the square of those deviations. So I can put it as, so for example, for sample 1, x1 bar minus x bar. Okay, would be the deviation. For sample 2, the deviation would be x2 bar minus this. X bar. So like that, I will calculate the deviations for all the samples, and then I will take the square of these deviation, and then I will sum it up. So in short, I can show it like this. For k equal to 1 to k, x k bar minus x bar whole square. Okay, the same thing here, x1. So where k will take 1, 2, 3, 4, 5 till k. Okay, and it will take the square of the deviation and then it will sum it up. So this is known as sum of squared for between the group. Now, the next is to calculate the variance, I need a degrees of freedom. So here, how many values we have? We have k values. So here you can take this particular entire group as one sample, okay, in which I have these k items. Okay, so here the total size of this whole sample is k. So here the degrees of freedom would be k minus 1. So k is nothing but, I'll write it here, k equal to number of samples. If you're talking about 3 samples, then k will be equal to 3. If you're talking about 100 samples, then k equal to 100. Now, we'll talk about, sorry, we'll talk about now variance, or else we call as MSS, or mean squared, mean sum of squared, or we can call it as variance. So what is the formula of variance? It is sum of squared by degrees of freedom, this, right? So here we can write it as, I'll put it as SS by DF. Okay. So 1 second. Instead of making it as generic equation, I will put it as SS between divided by DF between. Guys, please stop me if you have any confusion anywhere, okay? So for between groups, we find out the sum of squared deviations, and then we calculated the degrees of freedom, and then we calculated the variance. Variance is nothing but the ratio between the sum of squared by degrees of freedom. Now, next we will do it for within group. So this is something you have to pay attention. Okay. Now within group is, for every group, I'll find out the variance within the group. So what would be here for first sample? The mean is x1 bar. So I can write it as I equal to 1 to n1. So let's suppose the sample size is n1. So I equal to 1 to n1. And here the formula would be x for sample 1 ith term minus x1 bar whole square divided by n minus 1. Is this clear, everyone? Every observation in this sample 1, I will consider and I will find out the deviation with this sample mean. And that deviation I'll take a square and then I'll sum it up and then divide it by the degrees of freedom. Like that, I will do it for every sample individual. And then what I will do is I will then sum the entire variance. So now that would become my within group variance. So I will write the formula like this. Here I will have two summations. One summation at a group level. For every group, I have to make the summation. And another would be at a individual group level. Okay, where I will take I. And I will take X, K, I, kth sample. Here I have taken the first sample and the ith term. Here I have taken iterating for all the k samples, k groups, ki minus x k bar whole square. Clear? Now degrees of freedom is, I will take the sum of all the degrees of freedom. Okay, which would be n1 minus 1, n2 minus 1, n3 minus 1. So like that, nk minus 1. If I take the sum of all these things, what it will be? N1 plus N2 plus N3 till Nk plus K. This 1 will add, right, to K number, K times. Okay, so overall I can call it as K. And this,
Minus K, no?
sorry, minus K. Right. Thanks. It would be minus K. Okay, so this N1 plus N2 plus N3 till Nk, I can call it as N, or I can call it as capital, not capital N only, because I'm talking about sample only, small n minus K, where N is equal to the sum of sizes of all the samples. Okay. So now this degrees of freedom would be N minus K. Now here again the same thing. Now here SS within by DF within will be my variance. Now the F is simple, F test. Okay. Now F test is equal to MS between divided by MS within. Or else you can call it as variance between by variance within. So this ratio is nothing but your F test statistics. Now this F test, you have to go and refer to the F distribution to calculate the p-value. So this p-value you have to go and calculate for this test statistics at n minus 1 degrees of freedom. Sorry, k minus 1 degrees of freedom and n minus k degrees of freedom. Okay, so as in T distribution, we have seen that we are considering only 1 degrees of freedom. Okay, and in one sample, in two samples, we are referring to 2 degrees of freedom. Here also, we cannot take degrees of freedom for all the samples. So instead of that, we are taking the degrees of freedom between the sample and the within the sample with that test statistics. So we will refer to this F distribution and consider all these different parameters to calculate the p-value. Once we calculate the p-value, that we have to compare with alpha value, and then we will take the decision accordingly, whether we have to go with the uh, whether we have to go with null hypothesis or alternate hypothesis. Is it clear?
Yes, sir.
Simple, right? So if you want to take the notes, I'll give you 1 minute. Okay, so you can note it down. Now, this analysis of variance, I'll give you a couple of more examples where all we use. So now here I've given you an example where you have multiple population and you want to check whether the population mean for all those populations are same or not. So what you did is you will select a sample from each of those populations, and then you will apply this ANOVA test, and then you can compare the sample means for all the samples, and then you can conclude whether the population means are equal or not equal. So that's one of the use case. Second example is, for example, now you want to do the impact analysis. Impact analysis in the sense, let's suppose I'm running a e-commerce website, and I want to see that whether males are making more purchases or females are making more purchases. Okay, so now this become two sample. Let's suppose I'll make it more than two samples. Let's suppose I make a regional sales. I want to see whether I'm getting more sales from Hyderabad or from Bangalore, from Chennai or Mumbai, from all those four major metropolitan cities, from where I'm getting the more sales, or whether it is like similar sales I'm getting from all these major cities. So what I will draw is I will draw some samples from each of these regions as a sample, and then I will calculate the average sales, which is coming out from each of these regions. And then I will go and perform this ANOVA test on top of it. And then if I find that the sample means from each of these samples are not same, the population means are not same, then I can conclude that now there is a regional effect on my business. All the regions are not same. They are not uh, they are not giving me the similar business or similar revenue. So there is an impact of the region. Now, in what all ways this information or this analysis would be useful for me? Let's suppose I want to build a predictive model to predict the sales of my business. Now, as my sales, I have statistically concluded that regional is impacting my sales, then I will include that regional parameter or feature into my data to train my predictive model. So here what I have done is I've used ANOVA to select the important features which I should consider to train my predictive model. That's something, okay, I was referring to where this something we will see in machine learning classes for feature selection, which of the features are important, okay, which we should consider. That's something we will do it by using this. We can do it by this ANOVA test. Now, for example, now in all the region, I'm getting a similar sales. Do you think now I should include a regional information? No, because there is no variation. So as we are seeing, right, between variance, within groups and between groups, and I find that there is no variance between the groups, then no point of considering that regional information, because that will not give any information to my algorithm to understand that, okay, if it is a Bangalore region, then sales has to be high, or if it is a Hyderabad region, then sales has to be high. Okay, that kind of information the model will not get by this regional feature. Okay, region feature. So in that case, I can go ahead and drop that region feature. I will not include that in my model training. So for feature selection, also we use NO. So we have seen two different examples. One is like for strategic decision, you can use this ANOVA, where you will understand that all your regional sales are equal or not. If not, then you can go ahead and focus on one particular region where the sales are less. Or else you can, if you want to build some predictive model, then you can include this region feature if it comes out as a significant feature, which is impacting your sales. So these are the two major usage of ANOVA. One is for feature selection and another for your strategic decisions. Now, if you see that in all these samples, we have considered the numerical variable, because in the numerical variable only we can calculate the mean. Okay, on the categorical variable, we cannot. So if you are focusing on the numerical variable, then you can go with ANOVA. If you are focusing on categorical variable, then you go and perform the chi-square test. Now, what is this chi-square test? Now, again, I will take this is for categorical column. If we are having multiple samples. Now, in the multiple samples, the proportion of a particular event or particular object. Okay, if we go and calculate, for example, P1 hat, P2 hat, P3 hat, okay, and P4 hat. Now, if I want to go and compare whether all these proportions are same or not same, there we will go and perform this chi-square test. This is for proportions test. Okay. So here this chi-square is also denoted by something like this. So this is the notation for chi-square. Okay. It's not X, but this this will be peak. Okay. So this is denoted as chi-square. Okay, so for this chi-square, again, there is only one hypothesis where you will say that all these are equal. The population proportions are equal. That's something we can infer. That would be my H0. And H8 is population proportions are not same. Okay, just like ANOVA. This is the only hypothesis which we can uh, have, for chi-square test. Now the second is, now I will go and calculate the test statistics, denoted as this. Now the formula is very simple. It is observed minus expected whole square divided by expected for I equal to 1 to k. So this is k, this is k, this is k. Sorry, I. So that will iterate for k samples from I equal to 1 to k. Okay, so this again, example we will discuss. So once we calculate the test statistics, we'll go and find out. And for this, again, we have a different distribution, guys. We have a chi-distribution here, chi-square distribution. Again, is a different distribution. For this distribution, again, we have a table which will help us, to calculate the probability. Okay, and based on this distribution, we calculate the p-value, and that p-value will compare with alpha, and then finally we'll take the decision. So I'll not go much into the mathematics. Okay, we will look into the example and then we will understand. But before getting into the example, let me conclude that with a particular flow chart. Okay, and that flow chart, if you remember, all that we have discussed, you can relate and you can able to identify which test you have to make. So this is something I will request you to take the notes. So when we are talking about hypothesis testing, we talked about one sample, we talked about two sample, now we talked about more than two sample. Okay. Now in one sample, again we talked about mean, which we called as quantitative or continuous data, or else there is a proportion. For proportion, it is a qualitative. Okay, so these are the two tests which we can perform in one sample test. Okay, and when it comes to mean test, guys, what are the two scenarios which we have discussed? We have discussed when sigma is known, when sigma is unknown. If sigma is known, what test we have performed? We perform Z test, right? If sigma is unknown, then we have performed T test, right? When it is a proportion qualitative, there is only one single option, which is Z test. Okay, which we have done on the proportion. And you know what is the formula, all those things. You can refer to the material or else you can refer to the recordings to understand what are those things. Okay. Now again in two samples, we have mean test and then we have proportion test. Okay, so in proportion, again, it's simple. It's only Z test. Okay, what we have done, two sample proportion test. Here we have referred to Z distribution. When it is mean, then we have two different, again, possible, scenarios. One is like for independent samples. Second is for dependent sample. For independent sample, again, there are multiple scenarios. One scenario where variances are known. Okay, sigma is known. Population variances. Okay, sigmas are known. For sigmas, if it is known, then we go and perform the Z test. If sigmas are unknown, then again we had two different scenarios. One is equal variance and another is unequal variance. In equal variance, we go and perform we call it as pool test. Okay. But it is nothing but your t test only. We use t distribution only. In unequal, we go and perform the t test. So there is a same t test, but we have seen the variance, right, in the formula of calculating the test statistics. But it's a same distribution which we will refer to calculate the probabilities. For the dependent, we have seen we will go with that called as pair test. Again, here we will go and use the t test only. So in the pair test, what we do is we find out the differences of the values coming out from the two sample. Okay, it is only one single sample, but the scenario is like we calculate the values before the experiment and after the experiment to generate the two samples. And on that, if we go and perform, then that is known as pair t-test. Here, the samples are called as dependent samples. In this case, these are called as independent samples because the samples are being derived from two different population. Okay, so this is for two sample. And finally, what we discussed today for mean and for proportion. For mean, we go ahead with ANOVA test. And for proportion, we go ahead with chi-square test. So this is in nutshell about the hypothesis testing. And here in all these scenarios, we have multiple tests. We have lower tail, we have upper tail, and we have two tail test. Here we do not have three scenarios. Here we have just one scenario. Okay. Is this clear? Any questions? So this is the overall scope of hypothesis testing, guys. One sample, two sample, greater than two sample. If you have any questions anywhere, please do let me know. No questions? Are we clear on this?
So mean here is numerical and proportion is categorical, correct?
Categorical. So in any data, okay, we will find only these two different kinds of variables. So let's suppose we have V1, V2, V3, V4. Like that, we have n number of variables. So now these variables would be mix of continuous or category. You take any scenario. Okay. For example, age. I'll give you a variable name. Now you tell me whether it should be continuous or categorical. Let's suppose age. Is it continuous or categorical? Guys, come on. Age. It's a continuous data, right?
It's a continuous
numerical, right?
numerical.
Weight, height, temperature, pressure, voltage, all these are continuous. You can take any numerical value. Now, let's suppose if I talk about country, if I talk about gender, so country has a limited, okay, you will have a limited countries, right? So those are the categories because you can categorize your data based on the country. You can categorize your data based on the cities. You can categorize your data based on the regions. So all these you have to identify which of those columns can help you to categorize your data. Now that will become your categorical column. Now, for example, the same age, if it is mentioned in your data in the form of interval or in the form of group, for example, age is mentioned as 10 years to 20 years or 20 years to 40 years or greater than 40 years. Now, this will become the categorical column. If the age is measured like actual age is captured, that particular variable will become your continuous variable. Few people may say 11, few people may say 12.5 years, 14 points. So here you do not have any control, any restriction in terms of capturing the values. Here in categorical, if you are talking about 4 groups, then you have to go ahead with those 4 groups only. If you are talking about uh, cities, then your data should be mapped to those 4 cities or 5 cities which you have considered. So like that, in any data set, you will have primarily these 2 variables only, continuous or categorical. Now, even in machine learning algorithms, if you are predicting the continuous variable, those kind of problems we called as regression problems. If you are predicting the categorical column, then we called as a classification problem, because here we are classifying, okay, a particular event. Either it is, for example, failure events, machine failure. So here, that particular column, which is capturing the machine failure, either as yes or no, will be my categorical column. And if I'm going and building a predictive model on top of it, then it becomes a classification model. If any new event is coming, I have to classify whether that is a failure event or it is not a failure event. So that becomes my classification. Okay. If you want to categorize a particular customer, okay, whatever groups you have decided, now that becomes my classification problem. So whether it is a potential customer, whether it is not a potential customer, that's something I can categorize. So in any data, if you are analyzing the continuous column, then you can go ahead with this quantitative test, okay, or the mean test. If you are going with a categorical variable, then you can go ahead and perform this qualitative test or a proportion test. Okay, so these are the only 2 major scenarios you will get, and your hypothesis testing will be around those 2 scenarios. Either it would be mean or else it would be proportion. Now you have to decide whether it is a 1 sample or 2 sample or more than 2 sample. Accordingly. Clear? Perfect. So now what I will do is, without hurrying too much on this, firstly you digest this, okay, understand this entire picture of this hypothesis testing, go through the material, and tomorrow what we'll do is we'll take a couple of example in each of these areas, and we will see that in Python how we can do that. Okay, so take your time, understand this, because I know all these together, uh, to digest it, may take some time. So because one after the another, we have discussed about so many tests, right? So with this and this something, okay, you create this chart in one A4 sheet paper and stick it onto your wall, okay? And you keep seeing this particular flow chart often, and practice on couple of exercises, then this hypothesis testing will be completely clear to you guys. Okay. So do that, because it is not a complicated, but it is a confusing part, because so many tests, so many scenarios, so many variations. So that may confuse you. Okay, so just build this chart, understand it, take your time, and tomorrow we will take examples. Otherwise, your examples you will not understand. Okay. So first you understand what are different scenarios, and then we will take the examples tomorrow. So as we have time, if you have anything else to discuss or anything related to whatever topics we have discussed in last classes, feel free to ask. Okay, this is more of a generic discussion we can have, in the time remaining today. You can discuss anything, whatever you want to discuss. Any concerns, any comments, you're most welcome.
Shrikant, just one question here. Any
Yeah.
any document or any website you would like to refer in case you want to understand more on this Just like
Yeah,
for Python, you
I,
get
I can
W3 skill.
yeah, I can recommend you one textbook, okay, which is very good on which I felt because I read, and if you, as I mentioned, right, I've been telling you in different statistical books, okay, there is a different way of explanation of this hypothesis testing. Yesterday only I shown you that hypothesis. Somewhere it would be equal to, somewhere it would be mu1 minus mu2 equal to 0. Okay. So different books will have a different representation. So parallelly, I would not recommend you to refer to multiple textbooks because that will further confuse you. And even, on the online also don't refer to multiple websites because
Hmm.
every resource will have a different way of explanation. Stick
Hmm.
only one. So I will give you one, I'll refer you one good textbook, okay, which was been referred by my professor, statistics professor. So I felt that is very written in a very layman language. Basically, that is for business folks, how the business folks can understand the statistics. It is written in that way. So it is very simple in a layman terms and you can easily understand. So I will share that on Teams channel. So if you want, you can buy it. However, see, you should go and refer to the textbooks only and when you at a high level you have got a pretty good picture. Okay, then only you go in deep. Otherwise, you will get lost somewhere. And I would not recommend you to refer to any textbook at this point in time because see, as we are moving, we are getting into much more advanced topics of data science. We will get into machine learning. So whatever topics we are covering, I think that is good enough. To whatever extent we are covering in the class, that would create a very good base and foundation, to understand the machine learning. Now, in this journey, okay, if you go and try to understand in more depth, there might be a chance that you may get confused and your basic understanding about certain concepts may also go away. Okay, in that case I would rather ask you to avoid getting into much more details because these are good enough, to understand the other advanced topics as we go along. Once you are solid, once you understood from all the aspect of each of these topics, then you can go in detail in each of those areas. But at this moment, just maintain this, okay, this much level of understanding. Later, you can go in depth. But however, I will refer one good textbook, on statistics, which you can go through.
Okay.
All right. And the material which I've given, please go through it. That's something I've referred to multiple textbook and then created that content. So I think that is good enough, to for you guys to understand all these topics to the extent what we are covering in the class. For that, it is good. Anywhere, if you feel, as I from the beginning, I'm mentioning you, whatever topics we are covering, understand the application part of it. That is more important. Give more time and put more efforts in understanding how those topics are applied, okay, to solve a problem rather than getting into a subject. Because you see that in Python, with one single line of code, we are solving this hypothesis testing. So no point of going and understanding the mathematics. Now, because in the real practical scenario, to be frank, nobody knows mathematics. I'm saying I'm talking about senior people also. As I'm teaching, I'm into this teaching field. So there's a reason I remembered some formula and all those things. But the people who are practically doing, who are on the field, so they don't even encounter these formula. Okay, and there is no need also. So just they know that okay for pair t-test it's a different formula. For other pool t-test there is a different formula. They just know that. If you ask them the formula, they won't be able to tell you. So in the practical scenario, you just need to understand where to apply which concept, okay, and how to apply it by using Python or by using any other tool. So you put more emphasis on that side, on the application side. If you have any questions like where, Shrikant, do we use one sample? Where should we use two sample? And what is the need of doing this hypothesis testing, ask those questions 100 times, I will answer because that is more important. Okay. And after that, we will talk about correlation analysis and statistics and regression analysis. And after that, we will get into core machine learning. Okay. Any other thing, guys, you want to discuss?
Can you repeat the book names?
Uh, it's a business statistics. The book name is Business Statistics. One of the authors I'm forgetting. There are two authors. One is Excel. So I will share that on Telegram channel. It's
Sure.
ACZEL, the name of the author. Okay, and I think there is one person, I think Subramaniam or something. Okay, so I need to check it. I will share the complete name, book name, and the author names.
Thank you.
Yeah, because in that book they have explained the topics, the concepts, and also the application of those concepts. Because that is more important, right? As I'm mentioning. So that book covers both. So in that way, I like that book. And they also give you CD now. At that time, they gave CD, but now I think everything will be all the data, everything will be shared with you through online or something. They may give you some online link from where you can download the data, and they will also provide you an Excel file. So all those statistics and everything, all those exercises, they have done it in Excel. But now currently nobody is doing in Excel because now we have much more sophisticated tools and all those things are available, right? But in that particular book, they will refer to Excel. So in Excel, how you can do in that way, you can also understand how these hypothesis testing can be done on Excel. All right. So anything else? And guys, here I will give you some suggestion and advice. I don't know how much time you guys are spending on a daily basis. I would advise you and suggest you to at least spend 2 hours in a day, apart from this class. Until unless you don't spend and you will not follow any discipline and you don't have a regular, uh, what do you say, you don't take out regular time to to revise these topics and to go through these topics and for practicing, it would be hard because now relatively we are going slow, but after this we will pick up. There are so many topics which may come, and if you are lagging behind on these topics, then further lot of things will get pending, and later if you think of coping up, it would be difficult for you to cope up, and by the time you will realize you are late and the course will get over. And end of the course, then it would be a complete failure and you won't get anything out of this course because it is a fast crash course. It is a boot camp course. We will cover the topics at a higher pace, okay, with a faster pace. So until unless you take out time every day, 2 hours, and revise the topic, whatever has been taught, and if you are having any questions or if you are not clear on the topic, I would suggest you to get it clear in the next class only. So if you are in machine learning at that moment, if you come and ask me what is hypothesis testing, sorry, I won't be able to explain you to this detail. Okay. So two things: regularly take out time, keep keep studying this particular subject, whatever topics we have covered. Refer to the handouts, refer to the recordings, refer to the exercises, what we are doing. Okay. Simultaneously practice Python. That has to be continuous. So you have to get a good hands-on, you have to get the complete, um, you have to get comfortable on that Python. So that only you will get if you continuously practice on Python. Because it would take years together, to get to become a good Python programmer. So I'm not saying you to become a pro, but at least you should be comfortable. if someone is sharing you the Python code, you should able to understand that Python code. You should be able to tweak that code. So that will happen more often in the real scenario. Somebody is working on one particular thing, they may share that code with you, and from there you have to start developing, start working on that particular code. So you should understand what that person has done. You should understand what else need to be done. If there is any bugs in the code, you should know how to fix it. All that will happen only by practicing. Do not think that at the first go, if you are not getting errors, then you cannot become a good programmer. So good programmer is somebody like who is not one who writes a good program, but he's the one who can debug the code, who can optimize the code. If you're getting the error, try to fix it. How you'll fix it, it's your wish. Okay. You try various options and fix it, or you go and do some research on the website and find out how to fix that particular error. It's up to you. Okay. Until unless you know how to fix the errors, you can't be a good programmer. So these are the things which I would recommend you should practice on a regular basis. Otherwise, this whole course would be a failure for you. It would be a complete waste of time and money. Again, you will be back to zero. Because these are all interdependent topics. Okay, if you say that, okay, fine, statistics is gone and gone, it's fine. Now from here onwards, I will concentrate and I will follow a proper routine. It will not work out. If you want a break, I'm happy to give you a break for a couple of days. I don't mind, in stretching this course for if you are not in hurry. If you are in hurry, then we will take continuous classes. If you want a break, let me know. We will have a logical break between the topics, get it onto speed, and then we will pick the new topic. Okay, I'm fine with that. But keep practicing this. And one more suggestion is create your own notes, handwritten notes. Okay, just lying down and reading a book as a newspaper, okay, will not work out. And that we all know. This is not something, okay, you all are not aware of, right? We did our graduation, we did our schooling, and we know how to study. Until unless you take pen and paper and write in your own handwriting, okay, and create your own notes, it would not be effective. Because I'll tell you how. In this case, why is it important? Because see, you have to face the interview, right? And in the interview, you have to explain a particular topic, and we cannot explain it in a bookish language. Okay, we cannot buy heart the way we used to do in school days, right? We used to buy heart things. Now here you can't buy heart because your questions would not be a fixed questions. People will tweak the questions. People will ask the questions in different ways. Then your answer has to be changed. So you have to what you have to customize your answer based on the question which is asked, right? So that only you will get it if you understand the concepts in detail. And you should have to frame those sentences on the fly. So I'm saying write, so read about a particular topic and write and create your own notes, write in your own handwriting. Okay. So for example, somebody is asking about hypothesis testing. How you will explain hypothesis testing? Somebody will ask you about two sample tests. How you will explain about two sample tests? Refer to the some bookish language, but it should not be completely bookish. It will clearly interviewer will understand. Okay, he is like uh, is talking completely bookish, right? So it has to be completely in your own language. And second thing is like, do not directly jump into the technical part of formula. If somebody is asking, right, what is one sample test, do not get into a formula like here we will calculate Z, which is equal to X minus mu by sigma. No, that is very kiddish way of answering the questions. Do not jump into the technical. Always talk on the application side. One sample test is generally used, to infer about the population. Here we refer to only one sample. And based on that one sample, we'll try to infer about the population. Here we can frame multiple different kinds of hypotheses. It could, and then we can perform either lower tail test or upper tail test or two tail test based on the kind of hypothesis which we have developed, looking at the problem statement. So this is how, on a high level you have to frame. And here I'm not reading something and answering. It is something I have framed this answer on my own. So that will come until unless you read, you put your thoughts on the paper in your own handwriting and as your own notes. If you don't do it, you will not get it. However, whatever level of knowledge you will gain, if you don't able to articulate it, if you don't know how to present it, it's a waste of that knowledge. Okay, and in the beginning, I have mentioned, right, your presentation skills are required in data science. And in the interview, for whatever job you go and face the interview, it is those few minutes where you have to impress that particular interviewer. So it would be your body language, it would be your confidence level, it would be the way you are answering those questions. So your answer has to be relevant. It has to be on the application side rather than on the technical. Here you are not uh, facing any what you say Viva, right? So in the Viva we go and answer technically, but it is an interview. So mostly people will judge you on your understanding about these topics and what level of knowledge you have in terms of applying that knowledge in solving some business problems. Okay, so consider all these things, whatever I have suggested you, and please follow that. Otherwise, if you and spend time. So there is a word known as smart learning, guys. We have to do a smart learning. And why I'm telling based on my experience, because if you look at my qualification, I've done a lot of things, right? In my schooling, I took both maths and biology both. So these are two different subjects. To understand maths is different to understand biology. Biology is more of a you have to mug things, right? But mathematics is more of a practical, right? So I have to deal with these two. Then after that, I've prepared for medicine, I've prepared for engineering. Altogether, a different kind of learning needs to be done, when you are preparing for medicine and you're preparing for engineering, right? And finally, I landed up with engineering because mugging was not my cup of tea. I couldn't able to mug all those big books, right? There's so many scientific names and all those things I couldn't able to remember. So finally, I took a break of 1 year. After that, I realized, okay, I cannot do that. And then I moved to engineering. After doing my engineering, then I did my MBA. Again, different mix of subjects. And for that also, I need to apply for the exam. I went with an exam, then I cleared it, then I got a seat in MBA. And after my MBA, then I also prepared for civils because I wanted to go and do it in government exams. So in all throughout this learning, I what I learned is until unless you do a smart learning, you cannot succeed. If you be a parrot, like if you keep mugging, our brain has limitations, right? We are not AI machines. We are a humans, and we have a certain limitation. We cannot remember certain things beyond certain limit. Okay. So what you have to do is you have to do a smart learning. And that I learned while I was preparing for civils. Okay, I was able I attempted only once and I cleared the prelims, but I couldn't clear the mains and I didn't have that much patience, to go for the next attempt. But what I learned is there you have to cover a lot of subjects. You have to study about current affairs, everything you have to keep it in mind. You have to study about history, geography, and then all that subject, how they are related to your current affairs. That's something also you have to understand. So you have to be very specific there. You have to be very quick. And it and you can only do it through particular discipline. That morning I will study half an hour newspaper. After that I will study this something, okay, and then you have to prepare a crisp notes. Always you cannot refer to the books, right? You have to prepare the notes every time you have to revise those notes. Then you have to proceed. So that comes only through proper discipline, guys. And with smart learning. And I've seen people spending 18 hours, 20 hours a day, but they couldn't able to clear. And I was surprised, if when I cleared the prelims. Okay. So this is something, okay, you guys have to follow because you are learning now and it's all about your career. You have to take it seriously, guys. You have to see that what all things are important for you to get a job. If you focus only on the subject, do not focus on the programming side and do not focus on the interview, on your communication side, on the way you communicate, you should answer the questions. Again, it's a waste. You have to keep a balance. And every day you have to keep measuring like where you're lacking, what are your strengths, what are your weaknesses, and you have to focus more on your weaknesses or development areas. Okay, and that's something if you follow even throughout your career, it will help you out a lot. Now also in my career at this level, I have to sit with my mentor. I have to frame my goals. He identify my areas of developments. Okay, and I have to focus on that. And accordingly, the goals will be decided. The people who are experienced, they can relate, right? It is like our lifetime process. We cannot say that at any juncture, we cannot say that, okay, we know everything. There has to be a continuous learning, and that continuous learning, you have to follow a proper discipline. Okay, and that too, you have to do some kind of smart learning. You have to pick few resources, genuine, authentic sources, and you have to go through with those sources and you have to read continuously to upgrade or to update yourself in this data sense. Otherwise, it would be hard for you to sustain. And it is applicable in every field, guys. Okay, even the doctors, engineers, they have to upgrade and update themselves. It's not something once they have studied and everything is done. Okay. So please follow these guys, these guidelines. I would have, told this in the beginning, but people who are doing this, then good. People who are not doing that, do it. It's not too late now. Okay, and if you need a break, then let me know. We can have a break for a couple of days. Even I have to travel next week. So we can see in that time if you want a break, I'll give you a break. Okay, and then we'll continue from there. All right.
How many more classes are left?
I don't know the number, but a lot of topics are still left. We have to cover machine learning, then we have to cover Spark, then we have to cover deep learning, then we have to cover Tableau.
Tableau.
Yeah.
Okay.
So roughly again another 2 months, 8 weeks,
Oh,
possibly.
okay.
But again depends, right? We may go fast, we may go slow. So but roughly it may take plus
Sure.
minus 2 months.
Thank you.
Yeah, Srinath, my suggestion is give us some exercise in between, instead of just pushing through the class so that we can apply from our side and then
Definitely,
come back to you. Yeah. That is
definitely.
the best way.
As I mentioned, after this, I'll cover a couple of examples and then I'll give you exercises as well.
Yeah, I mean, it'll allow us to apply at home. Then we can come back and do
I'll do
the
one thing.
same. Yeah.
I'll share the exercises today itself. Okay. Try to
Yeah, I
do it
mean,
manually, and then you can practice on Python. Okay.
yeah. I mean, just give us some time that, when you come to the class, then it is easier to recall.
Yes. Got it. Anything else, guys? Okay. Then thank you, guys, and we will connect tomorrow. Take care.